Hey APL class, we are going to take a look at the notes for particle motion on a straight line, so I'm calling this one 2.5b. Alright, so we're going to explore the relationship between a position function, velocity, and then acceleration. Okay, so and we're going to be talking about straight line motion, so that's either going to be horizontal motion or vertical motion. Okay, we're just assuming either it's moving up and down or it's moving left and right. They'll state that in the problem. Okay, so when an object moves, its position is a function of time. So position is usually where we're starting from, and they usually use an S for a position function, S of t. So that's what we have right here. And so it says for the S of t function given here, which is quadratic, show its position on the number line for these different times, time 0 through 4 seconds. Okay, so all that we need to do is just evaluate these. So we're going to find S of 1, and so we're just going to plug the 1 in there. Or actually, let's start with 0. S of 0, that's pretty easy to do. So if we put in 0, we know that we're just going to get -3. If we do S of 1, and I've already got this loaded in my calculator, so that's going to be -4. I know you guys can plug these in, so we don't need to do the calculations together. S of 2, if we plug that one in, we're going to get, I believe, a -3 for that one. S of 3, so if we plug a 3 into that quadratic, we get 0 for that one. And S of 4, if I plug a 4 in, I get 5. Okay, so these are my positions. So what they want us to do here is we'll just denote this on our number line. So at time 0, that's going to be the first dot that I put on here. At time 0, I have a position of -3, so I'm starting right here. Okay, now at time 1 second, I actually move to a position of -4. So I start moving this direction, right? So at time, this is at time equals 0 is where I'm starting here, t0. Then at time 1, I've moved to this position right here, okay? Now at time, I'm just going to kind of, move it left and right as necessary. Now at time 2, I've gone back to position -3, right? So I've kind of gone back here. So at t equals 2 seconds, I'm back to this position right here. All right, at time 3 seconds, I continue to move back to the right, and I move to a position of 0. So now I'm here. This is at t equals 3 seconds, right? So I'm kind of going this direction like this, right? So now I'm moving. I know I'm kind of, not exactly looking horizontal. It looks like kind of curved up, but just so we have a spot to right here, right? So we moved left for that first second, and then it looks like at 1 second we turned around and started moving right. Okay, so we're moving right, and then where am I at now? At 4 seconds. So at time 4 seconds, I have a position of 5, right? So I keep moving right, and then at this point here, now I'm at a position of 5. So this was at t equals 4 seconds right here. Okay, so the movement of the, of the particle, if we think about this, so it starts here, and it starts by moving left, and then after 1 second, it turns around and continues to move. So it starts here, it goes left, and then it turns around and continues to move the right, for the rest of that time. So it would make sense, on we know this is a parabola, our vertex is going to appear at a x equals 1 or t equals 1 and a y coordinate -4, but that's where it's going to turn back around and start going up again, basically is what happens with that function. But that's kind of how we'd model this position, okay? All right, so it says velocity. When an object moves, its position changes over time, so we can say the velocity, v of t, is the change in the position of the position over time, okay? So it's a rate of change. Position is a rate of change of or velocity is the rate of change of position. Okay, so we talk about rate of change. That refers to instantaneous rate of change. That's going to be our derivative function. So we know this to be the derivative. Thus we can say v of t is equal to s prime of t. So taking the derivative of your position function gives you your velocity function. Okay, so if we were to think about just a simple graph of this, right? So if we were plotting position versus time, right? If this is time here in, let's just say, so if this was in seconds, right? So if my x-axis, if the units on that were seconds here, right? seconds. And if on my y-axis I had feet or something, right, because that's my position. So I had feet here, and I had seconds here, right? And then if I had some different, if I had some curve or something, it was whatever it was doing, and I wanted to know instantaneous rate of change, right? So if I was getting the slope of this tangent line, what would that slope be? It would be feet, right? So it'd be like if I had a secant line first, it would be, I'd have time as an x-coordinate, feet as a y-coordinate, time as an x-coordinate, feet as a y-coordinate. And so when I subtract those, I'd have the difference in feet divided by the difference in time, feet per second. So hopefully that it kind of helps you understand. We're looking at a slope of a curve. With these type of applications, you've got a distance or a position for your y-coordinate, and you've got time, seconds in this case, for our x-coordinate. So you're going to end up with a feet per second in this case, or maybe it's miles per hour or meters per minute or something, but it's going to give you a velocity, right? And so that's why we say, given a position function, its derivative or its rate of change is going to give us velocity, okay? All right, now horizontal, we're talking about horizontal straight line movement. If we have a positive velocity, remember that velocity is a sign vector, so if it's a positive number, we know that it's moving to the right. If velocity is less than 0 or negative, that means it's moving to the left, and if it's equal to 0, it's not moving at all, it's stopped, right? With vertical, a positive velocity means it's moving upward, a negative velocity means it's moving downward, and obviously 0 is stopped. Okay, so, all right. So here with vertical, we talked about that vertical motion, up, down, and stopped. Okay, so speed. So speed is just the absolute value of velocity. So regardless of which direction it's moving, speed, we just want to know how fast it's going, whether it's to the left or to the right, or if it's up or down. Speed is the absolute value, so we don't include a sign for speed. All right, so speed of an object must be either positive or 0, meaning that it stops. We don't have any negatives for that. All right, and then we're going to throw acceleration into the mix here. So if we do the rate of change of velocity, so rate of change, right? So if we have feet per second, but then we do a rate of change of that again, that would put per second on it again, or feet per second squared, for example. So when we do the derivative of our velocity, or in other words, the second derivative of position, that gives us an acceleration function, okay? All right, so given a position function s of t, now we can determine both velocity and acceleration functions. So just kind of putting this into a practical thought, on your car you have two devices for changing velocity. What are they? Well, you're going to change your velocity with the gas pedal, right? And also with the brake. All right. So when we're talking about changing velocity, that's going to be your acceleration idea. Your change in velocity is your acceleration. Okay. So with a horizontal line, so we would say if you're of positive acceleration, you're accelerating to the right. If you have a negative acceleration, or if it's a negative, it's accelerating to the left. And if it's equal to 0, it's not changing. It's a constant velocity. So that doesn't mean, if acceleration is 0, that doesn't mean it's not moving. It just means your velocity is not changing. So you got the cruise control, right? It's just, you're just set at a certain speed. With vertical, if you have a positive acceleration, it's accelerating upward. Negative acceleration, it's accelerating downward. And velocity is not changing again. So, okay, so just because an object's acceleration is 0, that does not mean it's stopped, right? It means that the velocity is not changing. So what device on your car would keep your car's acceleration equal to 0? Right, I think I kind of already said that by accident. What keeps us at, in other words, acceleration equal to 0 means velocity constant, right? And so we can keep our velocity constant with our cruise control, so we don't get a speeding ticket, right? Cruise control. Okay, so we can use our cruise control. All right, also, just because you have a positive acceleration does not mean that you're moving to the, positive acceleration does not mean that you are moving to the right. For instance, suppose you're walking to the right with a velocity that's, positive, so that means you're walking to the right. All of a sudden, a sudden wind starts to blow to the left, where you have a negative acceleration. What would that do to your velocity, right? So if you're walking, with a positive velocity, walking, I don't know, 5 feet per second or something to the right, but then all this wind starts blowing from the left at 2 feet per second. That's going to slow you down, right? if you're walking into the wind, it's going to slow your velocity down. So what's going to do to your velocity? It's going to decrease your velocity, right? Velocity, or slow down, right? You're going to slow down. Okay, so here, let's take a look at this. So think about what that just said there. Okay, so if our velocity was positive, meaning we were walking to the right, but the acceleration was negative, which means it was blowing to the left, we had a negative acceleration, right? What does that mean? You know, what does that do to your actual speed or velocity? It means that your speed is going to be slowing down, okay? All right, so it says fill in each box with either the phrases speeding up, slowing down, constant, or stopped. Okay, so here's what we want to, this is what we kind of want to think about, right? So if our velocity is moving to the right, moving us to the right, now we're accelerating with it where we have a positive acceleration. Now let's go back and look at what that's telling us again. Okay, so if we're, let's just keep it horizontal. Object is accelerating to the right. It's accelerating to the right. Okay, that's what that, you know, so if we're walking to the right and we're accelerating to the right, does that mean are we going to be speeding up, slowing down, constant, or stop? Well, if they're working together, you know, I have a positive velocity, but also a positive acceleration. That's going to cause me to speed up, right? I'm going to be speeding up because your acceleration and your velocity are working together. So speeding up is what would happen there. All right. Now, in the next one, we see that we have. We're going to keep going across here. So I've got positive velocity, so moving to the right. Now my acceleration is actually accelerating toward the left, right? It's accelerating this direction, kind of like this, what we just said right here. You know, the wind is, you're walking or you're running to the right, but the wind is blowing back to the left, so it's slowing you down, right? So when they work in opposition to each other, it's going to slow you down. So that's slowing down. Okay, and if your velocity is positive, you know, you're going to be going at a constant speed here if your acceleration is 0. I'll just say constant speed, I guess. Okay, now here, if your velocity is negative, so you're going to the left, right? Let's think of it that way. If we're going to the left, but we're accelerating in the opposite direction, so I'm trying to walk left, but I'm accelerating in a positive direction, that means I'm going to be slowing down. Again, they're working against each other. So that's slowing down. Okay, here, walking to the left, accelerating to the left, right? So, or if you're thinking vertical motion, or if you wanted to, like, you know, you're jumped off the diving board or something, right? So your velocity is moving downward, but you're also accelerating downward, so you're going to be speeding up. Okay. And then if we have whichever direction you're moving to the left, but acceleration 0, it's constant speed. Okay. So that's constant speed. Okay, now these ones are pretty easy. If your velocity is 0, you're stopped. So each one of these is going to be stopped. Okay, so those are all stopped. So that's pretty easy. Okay, next idea here. So it says a particle is moving along a horizontal line with this cubic function, okay? Do an analysis of the particle's direction, acceleration, and motion, which means speeding up or slowing down, and then its position, okay? So here we've got, I kind of did some of the work here. So we've got S of t given here as this cubic function. So what we want to do first, and actually before we even do this, I just want to talk about the tips here. So what you really want to do here is you want to find the velocity function if you're first given the position function. Set it equal to 0 and solve, because what that tells us, when the velocity is 0, that tells us where the particle has stopped. And that's important, because when it stops, it's possible it's going to maybe change directions. Okay? Make a number line of v of t showing where the object has stopped, and then the sign and direction the object at times to the left and to the right of that. So we want to know, was it moving left or was it moving right on either side of where it was stopped? Okay, and assume that you're just working with positive times. We're not going to work with negative times. Then also find an acceleration function to do the derivative again. Set that equal to 0 to see where the acceleration is changing from positive to negative. Okay, so we're going to make a number line and show when the object has positive and negative acceleration, and scale it exactly the same. So that's kind of what I have set up here. I didn't rewrite these numbers, but this would be, the same time frame here. Okay, so we got the same things there. All right, and then make a motion line to kind of comparing where acceleration and velocity have the same sign or if they're different signs, and then we'll interpret whether it's slowing down or speeding up there. Okay, and then this is just our position graph at the end. Okay, so if we find the derivative of this cubic function here, so it's 3t squared minus 18t plus 24, and we're going to set it equal to 0, and we want to solve that. So we can solve it by factoring. I took out a 3, and then it factors into t minus 2 times t minus 4. So I should get t equals 2 and t equals 4. So those are the two times when the velocity is equal to 0, at 2 seconds and at 4 seconds. That's when we basically stop. Okay, so we want to put those marks on the graph. So at time 2 seconds right here, and at time 4 seconds right there. Okay, it's important to know when it's equal to 0. Okay, now what we want to do is we want to do some testing here. So on either side of this, what I want to do is test the, and I had this in a calculator already, so I know that you guys can plug numbers in, but let's just see what happens if I were to put in, let's say I put in v of 1 to test something that's over here on this side. So if I were to plug in, let's say, v of 1, and I plug that into my velocity function there, right? If I plug that in, I think I get 9 for that one. I get a positive value if I put that 1 in there. Okay. Yes, because that'd be 3 times 3 there. So that's going to be 9, and so that tells me, because I'm going to have some positive velocities going here. So anything, because it's 0 here, so that means everything to the left of that, at our these are called critical values. These are all going to be positive. If that's positive at 1, then everything's positive there. Now let's see what happens on the other side. So let's just test v of probably 3. So if I test v of 3, and I plug that into my velocity function, I end up getting a negative value. I get -3. Okay, so that means then I've got negative velocities in between here. Okay, so if this is horizontal motion, I'm moving right. There, I stop at time 2 seconds, and now I'm moving left between time 2 and 4. Now let's see what happens when I do greater than 4. Like, so if I put in a 5. So if I do v of 5, so if I plug in 5 next, I end up with, I think I get a positive number again. I get 9 for that. Okay, so now I go back to positive. So now I'm moving to the right again. Now because those are my only critical values here, these are the only times that it stops. It can't change directions again. Okay, so these are basically the directions. It's moving right. It stops at 2. Now it's moving left. It stops at 4. Now it's moving back to the right again. Okay, so this is basically what we have, and it's just going to continue moving to the right after that. Okay. So now with our acceleration function, right? So if we do our acceleration function, that means I need to take the second derivative of position, or basically, I just want to make this connection. The second derivative of position, which would be the same as the first derivative of velocity, is going to give me what I would call the acceleration function, right? So the derivative of this right here is going to be 6t minus 18. 6t minus 18. So now I want to set that equal to 0 to see where the acceleration would equal 0, and then that'll tell me where it might possibly change from positive to negative. So if I solve this, set it equal to 0, I'm going to get t equals 3, right? Add 18 and divide by 6. So I get t equals 3. Okay, so at that time, that's when I'm going to put a dot there. That's where I might have a change in my acceleration, right? So now let's test a little bit and see where the acceleration, so I'm going to test on either side. Okay, so I get equals 3 there, where there's basically no acceleration. Acceleration is 0. And if I were to test on either side of 3, if I would go, let's see, if I go a of 2, right? If I do a of 2, I think I'm going to find that I get, if I put a 2 in there, that's going to be 12 minus 18, that's going to be a negative number, right? So that's going to be negative 6. So this is negative here.
Hello, Cheyenne staff and students.
Oh, we got announcements coming on. But these would be negative
Teacher,
values here.
Staff,
Negative,
when the bell rings, you are free
negative.
to leave with students.
So,
Make
and then
sure
if
you
I test on the
buckle up.
other side of
Make sure you
3, if I
drive
test 4, so I
Once
do
again,
a of
teachers,
4,
when the
let's see
bell
what happens
rings,
there. So I put a 4, that's
please
24
leave with
minus
students and
18,
drive safe.
that's going to be 6. Okay, so I get 6 there. And so that's positive, so now I've got positive acceleration the rest of the way. It's only going to change that one time. Okay, so now we're talking about the motion, right? What's the motion change going to be? So what I want to compare is, you know, these values. I want to compare right in here, because wherever there's a change, what I'm looking at is I'm looking at positives and negatives and where those change. So here I've got same positive, so I got positive velocities, I've got negative accelerations. But then between 2 and 3 seconds, I have negative velocity and I've got negative accelerations, right? Now between seconds 3 and 4, I've got negative velocities and I've got positive accelerations. And then it looks like the rest of the way from beyond 4, I've got positives for both, okay? So that is really what I want to compare when I'm doing this, okay? So let's look at this. So because the signs are the same, positive, or actually they're opposite, positive and negative, that means that I'm slowing down, okay, I'm slowing, I won't write it down just because I don't have a lot of room there. But between seconds 0 and 2, I'm slowing down because positive velocity, negative acceleration. Between seconds 2 and 3, negative and negative for both, this is speeding up. This is going to be speeding up. Speeding up, all right, it's slowing down, okay? And then between seconds 3 and 4, negative versus positive, right? So that is going to be slowing down again. And then looks like the rest of the way, positive velocity, positive acceleration, this is all going to be speeding up again. Okay, so that's the way we do kind of this motion analysis. So we figure out where do we have positive velocities and where do we have negative velocities. Then we look at our acceleration, set that equal to 0, find where that's going to change, find where that's negative and where that's positive. Use the same scale so that now you can kind of compare where they change. You know, are they the same or are they different? If they're different, that's a slowing down situation. If they're the same, then you've got speeding up, okay? So this is this motion analysis. I know there's some of these questions on the quiz and on the test, okay? So this is how you do this process. Okay, I think I'm going to stop there for this video, and then we'll get into some of these word problems in the second one.